Ooh, a lot of chaos going on. There we go. So yeah, I don't. There was a big part of me. I was leaning towards the let's not do this. I think that might have just been me being lazy. But yeah, we're gonna spend a couple days expanding logs. So um, this is probably this will just some of you struggle with this a little bit just because there's a big variety of things, and as with all math, you just have to be good at like what's the first step, like where do I start? So um, I shouldn't expect you to guess this, but expanding logs is the dead opposite of condensing logs. So in the same way that you can put logs together that you have been, you can also pry them back apart. And each one has its place in math. So let's get good at expanding logs. So if you think about a log expansion, um, the most basic way I can say this to you is just think opposite of condense. So like if I gave you log of the product A times B, your job starting now today for a couple days is to think about like how did that get there? Like that is a condensed version of two other logs. Can you think of what they would have been? Very good. So an expansion is us just going backwards. So this would expand back out into log of A plus log of B. We talked about going the other way. We talked about condensing. So again, that's sorry, I thought I kind of said that, but I do talk a lot, so it's easy to stop listening. What we've done so far is take the logs when they're in this format that I'm underlining and condense them back into a single package. Today and tomorrow's objectives, or Monday's, whatever, are to now take and unpackage like a unzip file on like a PC or something like that. So we're unzipping the log into multiple logs. And of course, the other most common expansion you're going to see would be if you were given log of a quotient, like log of A over B, what would that break back into? Very good. Okay. So let's start with a couple super basic examples before we get to the weirder ones. Oh, let me show you one more thing, uh, just while we're here. Log of A to the bth. Very good. Well, you guys are really good at logs. So an expansion for this, the expansion that you'll always be expected to do is to basically take that power, that exponent, that little b, good job, Jared, and shoot him back down to his former home in the front. So a common expansion or an expectation is that when you see something like this, you bring the b back down and do b times the log of a. Okay, so those are the three primary expansions that we're going to work with. And now they're all just going to kind of start to jumble together. So you'll get two versions of today's assignment. As I go through my examples now, I'm going to start just kind of sequentially picking similar things from your worksheet, and we'll kind of see where do you hit the wall. If you do, maybe you won't. You're so good at logs, we've been doing them, and maybe you just won't ever get to that point where you go, "Ooh, that's hard." Like maybe we just breeze through today. So here's a mathematical example. So let's say I gave you log base 8 of 4/5. What would that expand out into? Log base 8 of 4 minus log base 8. Absolutely. Good. You guys have any issues with anything simple like that? Okay, let's take a look at this one. I'll just try to keep switching colors, make it a little less boring. Let's do log base 6 of x squared over y to the third. For the record, this is going to be a multi-step expansion. So The first and most obvious expansion is going to be the uncondensed, right? So what would it be first off? Beautiful. So eventually this doesn't take two steps. In fact, if you're super log expert, you might have already wondered, why are we doing that? Like there is a that to come after this. And yes, we will do more. And eventually you get to the point where you just see it and do it all at once. So this is log base 6 of x squared minus log base 6 of y cubed. But as mentioned before, what's then the subsequent expansion that we have to do? It is to complete, good job, to complete an expansion, you have to pull all your powers down and bring them down as multipliers. And so final answer to this would be 2, good job, Brooklyn, and whoever else, 2 log base 6 of x minus 3 log base 6 of y. That knowledge right there will get you through a lot of problems. Okay. Another common thing you're going to see throughout the assignment is something like this. Log base 5 of the square root of x. So yeah, right. So what are you thinking, Bryn?
2 log base 5 of x.
It's an excellent effort.
Would be 1/2.
It would be 1/2. And again, I know you dove right. You guys are so expert. You dove right in and just took a shot, and it was a gorgeous shot. But we got to remember that this part, I'm going to put a little gold circle or box around it. You've remembered that that interchangeably can be written as x to the power of 1/2, right? We agree? Remember that square roots and 1/2 exponents are like the same thing. We know that. We've been down that road. And so if I take out the square root of x and in its place, I put his exponent-y version, that's not a real word, but it should be, then I can see why the expansion of this would be 1/2 times log base 5 of x. Okay, everybody still okay? All right. Let's go again. I'm just trying to pick similar problems so that when I hand this out, you feel comfortable doing your thing. Let's do like log base 4 of x to the 4th, y to the 5th, all to the 6th.
Times the 4 times 5 is 4x.
Yeah, I'm gonna show you a couple of options. This is the first problem we've done so far where there's a couple of options. Everyone we've done so far has been very like, do it this way every time. This one you have options. And so I'll show you what I prefer, and then I'll show you an alternative method that maybe would make more sense to you. What I'm going to do is before I actually even acknowledge that this is a log problem, I'm going to take the exponent of 6 and I'm going to use my properties of exponents and I'm going to feed that 6 into the quotient. I think this is the quickest method. So what it's going to make for me is log base 4 of x to the 24th over y to the 30th. So you got to know your properties of exponents. Remember that a power and then you apply another power to it is a multiplication problem, right? And then from here, what would do you want to, anyone want to jump the middle step and go right to the answer? Are you comfy enough? Are you ready? What do we get?
24
Nice.
log 4 of x minus 30 4.
Yeah, I should have known this was going to go well. You guys are pretty good at this stuff. Now, if you're not comfortable with what Alyssa just did, if there's like an awkward space in this yellow box, if you're not comfortable jumping, don't jump. It's okay. There was a step in the middle where it would have been log base 4 of x to the 24th minus log base 4 of y to the 30th. And then you wind up bringing the 24 and the 30 down. Do it now, do it later. It doesn't matter to me. Okay. Still comfy? Okay, good. let's do log base 11 of the cube root of x times y squared times z to the fourth. If you ask me, this is really like the end of the difficulty climb. Like you sometimes in math just don't know like where's the top of this ladder. This is pretty much it, ish. So what are you thinking, Bryn?
Of x plus 1/3 log base 11 of 1. The log base 11 of 2. And then
You were doing a great job. I'm gonna go a little quicker, and you guys, what you're thinking in this case is, don't we have to break up the z? It was such an awesome effort. You're thinking in this case because we've done our jobs together. And if you're thinking you have to break up the z, you're thinking of something else. You're thinking of when we were simplifying radicals. And that's not what I'm about here. What I'm trying to accomplish here isn't about simplifying the radicals. It's about just expanding a log. I'm going to show you what the answer is, and then you're welcome to give me dirty looks if you want. It's fine. I can take it. You ready? So it's going to be 1/3 log base 11 of x. That came from these two red numbers right here. 1/3. Everybody see it? Okay. Now I'm going to undo that, and I'm gonna put a couple of yellow numbers now. Y is to the power of 2 with a root of 3. So I'm going to go plus 2/3 times log base 11 of y. Got it? And now that the cat's out of the bag, what, of course, is going to be the last part? 4/3 log base 11. And again, I wouldn't generally be skipping that middle step, but I'm getting the we get it vibe. And so we seem to be comfortable doing the expansion and the exponent drop all at once. And I'm totally down with that. Any questions? You'll have questions as in any math lesson. There's 50 different sort of little nuancy niche things that just come up, and so this is the basics of it. We're trying to just get it pulled apart into as long of a piece as we can. Expansion is basically just the dead opposite of condensing. We're like making it as many parts and pieces as we can. That's the goal here today. So all right, cool. I'm gonna hand out the assignment and you can get crack-a-lacking. Let's see. Stop recording.